I mean, truths no one told me.
When I first started coding, I thought the definition of good code was simple. If there were no red squiggly lines in my editor, I was a genius. Spoiler alert, I wasn't. Over the years, I've learned
Yeah, I won't lie. I myself, man, I hate to see like yellow lines, red lines, little like caution buttons. Like, bro, I hate to see those things, especially in my console as well. Like, bro, I hate to see like console errors and stuff like that. Like, live server isn't working or some, bro. Or sorry, um, your internal something is not connected. Like the 500 error. Like, bro, I hate seeing that in my console, man. It's so annoying, bro.
lines in my editor, I was a genius. Spoiler alert, I wasn't. Over the years, I've learned the hard way that there's a huge difference between code that works and code that's actually good. If I could go back in time and tattoo 5 programming principles onto my forehead, these are the ones I wish I'd picked. They're universal, no matter what language you write in. And if you actually use them, they'll save you from countless hours of pain. The first principle is that abstractions leak. On the surface, abstractions feel like magic. You use a framework, an ORM, or an API, and it hides all the messy details from you. But here's the catch. Every abstraction eventually shows its cracks. Imagine you're using an ORM to query a database. Life feels good until suddenly your app is slow because your single call has ballooned into 200 hidden queries. That's when the abstraction leaks. The lesson is simple. Tools save time, but you still need to understand what's happening under the hood. Otherwise, when things break, and they will, you're completely stuck. The second principle.
So basically, he's saying that you have to understand exactly what you're, well, like, basically, you have to understand everything. Not, okay, how can I describe this? Like, you have to genuinely understand everything that is going on, not just in like the front part of it, but even it, it's like, how can I put it? How can I describe this? Um, I think I think it's I guess I'm thinking like about a ship analogy, like with like a ship, like even though like there's the bottom layer of it where the engine and stuff part is, like there's still people on top that have to keep navigating the ship and stuff like that. So it's like you have to really just understand the ship, understand the programming that goes behind building that ship or using that ship.
Otherwise, when things break, and they will, you're completely stuck. The second principle is Yagi, short for you aren't gonna need it. When you're starting out, it's tempting to over-engineer everything. You think, I'll add this extra layer or design this plugin system because maybe one day I'll need it. 99% of the time, you won't. I once spent a week building a whole modular architecture for a project that ended up being a glorified invoice parser. Nobody ever touched the future-proof system. The best code solves today's problems. Add complexity only when you absolutely need it. The third principle is that readability.
So basically, what he's saying that just focus on building code that works, code that are functional, rather than like trying to make something look cute. To pretty much, I'm guessing what he's trying to say.
Today's problems. Add complexity only when you absolutely need it. The third principle is that readability is more important than cleverness. Yes, it feels satisfying to squash your entire function into one dense one-liner with fancy rejects or bitwise hacks. But here's the reality. Code is read way more than it's written. 6 months later, when you, or your poor teammate, open that file, you'll regret trying to look smart instead of being clear. A few extra lines with meaningful variable names and clean structure will always outperform a clever trick that only you understand. Write code like the next person to read has a baseball bat and knows where you live. Fourth, composition.
So basically, what he's trying to say is that write code that is clean, understandable, and when you look to return to it in the future, it's like you can compete. It's like you can. It's basically like it's how can I? Well, yeah, I think I was going good there. It's like you walking. Okay, nah, I won't lie, I don't have an analogy right now, but basically the point is that just made the code easier for you to understand, so that when you return to it in the future, you're not stressing to understand what you did, because you're just gonna put yourself into problems and just quit that project. And I've been there before as well, and that happens because one very main key thing, and I guess you should have discussed it as well, is that you should always add comments always have comments for certain sections so that when you return to a code, you understand exactly like what exactly you have to fix and stuff like that. Because when you don't add when you don't add comments now, it's like you return to this project and you're like, what the hell is going on? So yeah, you always
Write
add
code
comments,
that the
man.
next person to read has a baseball bat and knows where you live. Fourth, composition beats inheritance. Early on, I thought object-oriented programming was all about making giant family trees. You'd have an animal class, then mammal, then dog, then poodle, then teacup poodle that barks funny. The deeper the tree got, the harder it became to change anything without breaking half the system. Composition flips the script. Instead of chaining classes together, you build smaller pieces, behaviors that can be combined however you need. Think Lego blocks, not a family tree. A dog can just have a bark behavior, a run behavior, maybe a fetch behavior. That flexibility makes your code far easier to adapt and maintain as projects grow. And finally, the fifth principle, code is for
That part, I didn't really catch that part too much, but I mean, if you'll understand it, like, you can let me know, but I didn't really catch that part too much, to be honest.
easier to adapt and maintain as projects grow. And finally, the fifth principle, code is for humans first, machines second.
What?
Yeah, I think that now I get what you mean. Basically, what he means that, simply put it, is that you can't write something without understanding it. So if you write a code and you don't understand the code, how would the machine understand it? Simple as that, man.
I know this sounds stupid, but hear me out. Machines literally don't care. You could name every variable Yo Mama and jam your entire app into one file, and the computer would run it just fine.
Yep.
But humans, they care a lot. Your teammates, your future self, anyone who has to maintain the thing, they all spend way more time reading code than writing it. Studies even show the ratio can be as high as 10 to 1. Good naming, consistent structure, and
Yep.
clarity are not optional polish. They are what makes your code usable in the long run.
Yep.
Think of your code as a letter you're writing to the next developer, not just instructions to the compiler. And if you really want to become better at programming, you need to hone your skills with good projects that show your worth as a developer. Well, that's where Codecraft.
Yeah. And we are not watching this ad. But yeah, that's pretty much it. So basically what he's saying that, like, it just to like kind of keep it short and concise to touch on what he meant on this video here. It's pretty simple, man. Like, if you like, what people have to understand when it comes to programming is that you have to make it, you can't write code that you don't understand. That is one. You have to write code to ensure that you know what you're doing and you know what you're writing, like, you know what this code does, so that when someone, or you go to propose this code to someone, is that you don't look stupid explaining it to them, like, you know exactly what each code does, right? And he's saying that to also be clear, have like comments and those kind of stuff to your code. So it's basically, it looks nice, it's clean, and it's, you know it, it it's fun to enjoy, right? So yeah, that was pretty much it there for that. But now let's get into the project. And as I said, I didn't really, there's a few things that